let's set name equal to an empty space and age equals 0.
Hey,
I don't want this to
welcome.
be able to happen at all. Now when I run this, we don't have a name and we don't have an age. To make these parameters read-only, we can precede the parameters with that const keyword. Const string name, const int age. And you would probably want to add that to your function declaration as well, just to display intent. There, we have an error. Assignment of read-only parameter. Age and name is somewhere up here, but I don't feel like reading all of that. When we pass our string and our integer as arguments, what we're doing is effectively making a copy of name and age. Technically, we're not modifying the original variables. In this case, using the const keyword when we pass a variable by value isn't really that big of a deal, but it at least conveys intent. If we were working with reference data types, now we'll pass by reference. Well, now it's a bigger deal. We don't want anybody modifying the original name and age variables. Alright, everybody, those are const parameters. They are parameters modified by the const keyword that effectively make them read-only. Within a function, your code is more secure, and it conveys intent. It tells other programmers, hey, don't mess with these values. They're useful with references so that nobody can change the value found in that reference. Then in the case of pointers, nobody can change the address of where a pointer is pointing to. So yeah, those are const parameters in C++. Hey everybody, in this topic we're going to create a program to validate if a credit card number is valid or not. To do so, we'll need to utilize the Loon algorithm, which I've broken into these steps. If you need some test credit card numbers, you can always Google them. I found a bunch on this website. Let's just take this one for example. And to make this more readable, I'll divide this number into groups of 4. Step 1, we double every second digit from right to left. If the double number is 2 digits, split them. I'm only concerned with every second digit from right to left, so we can eliminate some of these that we won't be using. Then we're going to double these numbers. So 2 doubled is 4, 9 doubled is 18. Since we have the number 18, that's 2 digits. We need to split them. We'll split 18 to 1 and 8. Then 6 doubled is 12. We'll split that. Step 2, we need to add all of these numbers together to create a sum. The sum is 29. Step 3, add all odd number digits from right to left with the original number. So now we're only concerned with the odd numbers. Then we just add these numbers together. No need to double them.
Let's get to it.
The sum is 21. Step 4, we sum the results of steps 2 and steps 3.
Yo, you hear me?
29 plus 21, that equals 50.
Yo, you hear me?
Step 5, if step 4 is divisible by 10, that number is valid. We could say our result, modulus 10. If that number is divisible by 0, that number is valid. 50 is divisible by 10, so that number is valid.
This is part 1 of becoming a programmer. I'm learning C++ right now, basically.
Digit.
And
the parameter will be a constant integer.
Yeah.
That I will
So
number.
right now I'm trying to input
We'll need to sum
leap years. Where should I put
the
my
parameter is const standard
to check if leap years are right?
Number. Let's copy this, paste it, sum even digits. The parameter is the same.
This is what I call a chill place. I'm gonna bring my homies and after add me on Discord.
We do need to return
Chase
something.
FY. Alright.
Otherwise we'll get a warning.
Add you on Discord, man.
0 as a placeholder.
You got me too, man. Mine is I chill
Okay,
J.
let's begin with the main function. We'll need a
I
credit card
can't
number.
really do much right now.
Standard string card number. Then int results, and I will set that equal to 0 right away. We'll prompt the user to enter in their credit card number. Standard output. enter
if
a
you're
credit card number, standard input,
if
card
you
number. Result equals, we'll invoke the sum even digits function, pass in
if
our card
you're
number,
boom this
plus
is kind of hard. I'm trying to
sum
like
odd digits, pass in
okay,
our
so
card number.
basically let me explain this right now.
We'll need to fill in these functions.
uh
Let's begin with sum even digits.
I don't know where to start to explain, but
We'll create this.
integer
I'll
year,
create a
I'm
local
trying
variable
to
named
enter
sum
a
to keep
whole
track of the
number, so
sum.
I do integer
What we'll
year,
need to do is
and
iterate over
then
our card
to
number in reverse
display it
order.
on
We
the
can
output
treat
on
a
the
string
screen.
as an array of characters. We can iterate over that. So we'll
It's
need
gonna
to start
say
new,
enter a 4-digit year.
and we will iterate over this
Standard
card number in
character
reverse
output
order, starting from the
is
end. We'll need
basically
an index int
how
I
you show
equals.
characters on
Then we'll
output.
need to find the
It's like
size of our
it's in
card
his name.
number.
But like
There's a
okay, so
built-in function for
enter
that.
a 4-digit
Card
year,
number dot size.
and then
Now
sin.
arrays, they always start with
I
0,
just say
so we're going
sin,
to
but I don't know.
subtract
CIN
1. However, if we're
is
summing the even
what
digits, beginning
the
from the
user
right, we'll
sees,
need
how
a
user
second last
inputs
digit. So that
the
would
year.
actually be -2. The
It's
very
like the
last digit would be
response of the
-1.
user.
Our
When
index
you
I
need
will
the
begin
response
from
from a
the
user,
second
you
to
do
last position.
CIN.
I would like to continue this for
When you
loop
just don't
as
do an
long as
output
I
of the
is less
standard
than or
character
equal to
output.
0.
And
Then
then,
we will decrement I
yeah,
by 2. I
like,
minus
okay,
equals 2, as
say,
we need every
say if I were to
digit.
run this,
So we will take sum plus equals,
run,
then invoke the get digit function.
okay, G,
Get digit.
to run it,
Within the
you
get digit
gotta
function, as an argument, we're
come
going to
to
pass in
the terminal.
card
This is the
number
terminal, the
at
right
an
side.
index of I
The right side is the
times
terminal.
2.
I gotta put my
However,
shit
there's one more
smaller.
thing that we'll need to do.
Something.
With card number at index of I, we will
The right side
subtract
is the
the
terminal.
character
So
0. And here's why.
I'm doing
We're
G
currently
plus
working with a
plus.
string of
No, there's two
characters. You
pluses.
can also treat a string as an
Alright,
array
and
of
then
characters.
G
Each
plus
character, according to
plus
the ASCII table, has an associated integer value,
space.
a decimal value. If I'm passing one of these
You put
characters
the
as an
file
argument
name.
to my
The file
getDigit
name is the
function,
leap
we'll
year
treat that character
dot
as if it
cpp.
was its decimal
So
equivalent.
leap
According to the ASCII table, the character 0
year.
has a
Oh,
decimal value of
yeah.
48. The character
Underscore
1 is
year
49, 2 is
dot
50, and
cpp.
all the way up to 9, which has a
Into
decimal value
that,
of
then you
37.
do the
So if I'm
executor.
passing
That
in
was
the
just the
character
compiler.
at index of
Now you
I,
do the
what we'll end
executor.
up working with is the decimal
Compile and execute.
representation
Basically, you gotta
of that
compile and
character.
execute each
If we
time you run.
subtract the character
So
0
dot
or its
a
equivalent, 48, that will give us a
slash.
range of numbers 0 through 9.
No, no, no,
For
no, no,
example,
no, no.
the decimal equivalent of the character 9 is
Dot
57.
slash.
57
I'm still learning,
minus
guys. I'm still
48
learning. A
would be
dot.
9. You could subtract either 48 or the
And then it
character
says
0.
enter a
That would
4-digit
give us
year.
numbers 0 through 9, according to the ASCII
Okay.
table.
And then
Then we'll
see how I
multiply
could
that
enter a
number by
4-digit
2.
year, because
Then at the end, we will return
CIN,
whatever the sum is.
right here, the
Let's fill in
CIN,
this get digit function.
you can see my cursor, right?
Within the get digit
CIN
function, the digit that we're working with
X
was
is for the
doubled.
year.
Whatever number we
This is,
passed
it's
in
waiting for a
did
year, so I'm gonna
take 2
enter
digits. For example, like
2000.
9 times 2 is 18.
And yeah, that's
We need
it.
to split
That's
those
all
two
the
numbers
code
to get
is.
1 and
I
8.
need to
So I'm going to
basically
return
figure out how
number
to.
modulus 10
I want basically
plus
when you enter a year,
number
it determines if it's a leap
divided
year or
by
not,
10
and if it's not a leap
modulus
year,
10. That will
choose
split the
another
two
year
numbers.
that's a leap
For
year.
example, let's say our number that we're passing in
Choose
as an
a
argument is
yeah,
18.
basically a 4-digit
9
year that's a leap
times
year.
2.
It's going to check
18
if the
modulus
4-digit
10
year that you
would give
type in
us
is a
8.
leap year. All right, so let's get
18
into it.
divided by 10,
Back over here.
that would give us 1, since we're using integer division. 1
If
modulus
so,
10
basically,
is 1. 8 plus
I
1
can't.
is 9.
Okay.
Then we're just returning that
Okay,
number,
this is interesting
9.
because look.
Okay, that is the get digit
Alright.
function. Then we need to sum
I
the
need to
odd
do
digits. And really, we can just copy
all
this
the years. I need to
and
input
paste it.
all the years. But what's a faster way I could do that?
But there's a couple
Just
things
go
to
to. Because like you can't put in the invalid year. It's gonna have to be a 4-digit year. So
and then sum
okay,
plus
anyone guessing?
card number
1000.
minus 0. When summing the odd digits,
1000.
there's no need to
Alright.
double the odd digits. That's only with the even
1000.
digits. And that is all the functions. functions.
But yeah.
Let's close out of these.
Yeah.
So we'll have a
Yeah,
result.
so you go
Sum of
to the
digits
least
plus
number
the
and
sum
the
of the
max number.
non-digits.
You find the
If
least
result
and
is
the
divisible
max
by 10,
of
that number is valid.
how many. If I want a 4-digit year, a
Result
4-digit number in general. If I want a 4-digit number, you
modulus
just
10
find the
is
least
equal to
number
0.
and the max, and that is 1,099.
Then that number is valid. Standard
All right,
output
it's that simple.
card number
Let me enter it now.
is valid. Else, card number is not valid. Okay, let's try this. I'm going to enter in that original number that we worked with, that Discover card.
1,000.
Okay, enter a credit card number. I'm going to paste this, hit enter. That number is
That's
valid. Let's try that again.
and that's
so I'm going to enter in
the
the same card number, except I'll add
that's
one
the
caveat.
and operator.
That number is not valid. Hey, if you have your own credit cards, feel free to try them too
Yeah,
and see
that's
if it
the
works.
and logical
Alright, everybody,
operator.
that is a credit card
So if I want
validation
to say
program mostly for
1,000
practice.
and
If you'd
nine
like a
nine
copy
nine
of this
nine.
code, I'll post this in the comment section
So
down below.
year
Please make
less
sure that you do not enter in your own credit
year
card into the
is
comment section.
greater than
And
equal
well, yeah,
to
that is a credit
1,000.
card validation program using C++.
Not less than. Year gotta be greater
Alright,
than
everybody,
or equal
we
to
finally
1,000.
made it to pointers. A
We're
pointer
not
is
trying to
just a
go under
variable that stores
1,000.
a memory address of another
And
variable.
then it gotta
That's
be
it.
less
The reason
than
that we use pointers
9,999.
is because, well,
9,999.
sometimes it's just easier to work with an address. Here's an example. I have a stack of maybe 20 pizzas that I'm going to give out for free to my neighborhood. Instead of going around house to house carrying the free pizza and handing it out, it's a lot easier to go door to door and tell people where the pizza is located. Hey, there's free pizza at my house at this address.
Boom.
Come and get some.
That's simple.
That's one of the uses of pointers.
Oh, shit.
Sometimes it's easier to just work with an address. I'll tell people where the free pizza is rather than carry it around with me. So when working with pointers, we'll need to use the address up operator, which is an ampersand, as well as the dereference operator, which is an asterisk. Let's begin with the name. I'll create a pointer to a name. Standard string name.
I guess.
Assign your first name.
And then you gotta have closed brackets for each
Located in
one.
my computer's memory. To create a pointer, it should be of the same data type as the variable it's pointing to. When creating a pointer to a string, this pointer will be of the string data type, then type asterisk, that dereference operator. Then a common naming convention for pointers is you type P, then the variable name. But I'm gonna make the first letter uppercase. I will set this pointer equal to the address of that name variable. And there we go, we have a pointer. So if I was to display this pointer, standard output, P name, my pointer contains this value. It contains a memory address as its value. To access the value at this address, you would use the dereference operator. I'm accessing the value of that address that's stored within this pointer, which contains my first name. By using this dereference operator, I'm accessing the value that's at this given address, which contains my first name. Let's create a couple other pointers. Let's create a variable age. Int age equals make up some age. I'll create a pointer to age. The data type of the pointer should be the same as the variable. Int dereference operator P age equals the address of age.
Okay, hold on. Let me just go here.
Then let's display whatever value is located at the address that's stored within my pointer of ph. So we have my first name and then an age. I think I'm just going to add a new line real quick.
World.
Going back to that analogy with the free pizzas, I'll create an array of strings. I'll name this array free pizzas. I'll give this a size of 5. We have pizza 1, pizza 2, pizza 3, pizza 4, then pizza 5. Like I said in my example, it's a lot easier instead of carrying around 5 free pizzas house to house, giving away pizza. I can just tell people where the pizza is
If
located. I'll give them an
you're
address. I'll create a pointer to this array. We'll use the same data type. We're storing strings. Dereference operator. P. Free
if you're
pizzas. Now I'm going to attempt to set this to the address.
if we're gonna use the remainder sign,
and we're going to run into a problem.
400.
My array is already an address, so I don't need to use the address up operator. Let me demonstrate.
Alright.
I will display cout free
Year 400.
pizzas.
Year modular sign 400. Year remainder 400. If that year is evenly divisible by 400, then it's a leap year.
Value contained within my pointer to my free pizzas.
Yeah. If that year is evenly divisible by 400, then it's a leap year. That's why I'm doing. If it's a remainder of 400 and it equals
So those are pointers. It's
0,
that
then
stores a memory address of another variable. Sometimes it's easier to work
evenly
with that address
divisible.
instead of carrying 5 free pizzas with me and going house to house giving it away. I'll just tell people where the free pizza is. So those are pointers.
Evenly
Your
divisible.
assignment is to post a pointer in the comment section
Hold
down
on,
below.
let me see.
And well, yeah, that's an
I'm still
introduction to pointers in C++.
I'm still learning, guys.
San Pellegrino Italian sauces. Life is juicier with a full flavor taste.
If you check 100,
With SafeLight, you can get that fixed now and pay later.
Fix now, pay later.
always check 400, 104. If you want to check for a leap year, always check 400, 104. It is, imagine the year 2000. It is divisible by 100 and 400. If you check 100 first, you accidentally say it's not a leap year. Okay. Otherwise, if divisible by 4.
From launch to legendary with Shopify. Sell more with the world's best converting checkout.
If divisible by 400.
So you can scale further, faster. When it's time to grow, it's time for Shopify. Start your free trial.
No remainder.
My husband just wasn't.
So 2000 divisible by 400.
I love him, but it got to a point where we were both avoiding.
Yeah, divisible by 400.
XRX plus Climax control.
Divisible by 400. Then it's a leap year.
And stay hard with PE treatment to help him last way longer. And the best part is 100% online. No doctor's office, no pharmacy runs, just a simple.
I know I'm right,
and
but
a licensed provider recommended the right treatments for him.
I'm not checking the
Now
answer.
He's lasting longer, he's more confident, and we're actually excited to be intimate again. So if you're struggling with early climax, check out treatments.
Oh boy, we have an ad.
Seriously saved our sex life.
Oh, that's why you would want to do
Hey, what's up,
that.
everybody? So let's talk about
Makes
null
sense.
parameters. But first, we'll each know what a null value is. A null value is a special value that means that something has no value. When a pointer is holding a null value, that means that pointer is not pointing to anything. That's what we would call a null pointer. There is a keyword that represents that. Null PTR. PTR meaning pointer. It's a keyword that represents a null pointer literal. One of the reasons that we use null pointers is that they're helpful when determining if an address was successfully assigned to a pointer.
Output
If we create a
my
pointer, but don't assign
data.
it a value, we don't know where it's pointing to. It would be good practice that that pointer doesn't point anywhere. So let's create a null pointer. I'll create a pointer of the int data type. We use the dereference operator. Pointer. If I'm not going to assign this pointer
It would say
right away,
blank.
it would be
What
good
user
practice to
inputted
assign
is a
this
leap
pointer
year.
null PTR, null pointer. Later on in your program, if you need to assign an address, let's say int x equals 123, I would just take
Because wherever the CIN
the
whatever the sin is, whatever the user inputs because of your code CIN, it stays
to
there.
undefined behavior.
So you don't have
Or
to
if you
output
dereference a pointer
a
that's
whole
not assigned
cabinet
a
output of
value,
the user
well, that
output.
can lead to undefined behavior too. What some
It's
programmers
real
do is
simple,
that
man.
they'll check to see if their pointer is a null pointer before continuing, kind of like a system of checks and balances. We assigned our pointer the address of x. I would like to check to
Yeah.
see if my pointer contains a valid address before
Okay,
dereferencing
I'm
it.
typing so slow,
So we
bro.
could say pointer
Okay.
equals null
It's because I'm still learning,
pointer.
bro. This
Was my
is
pointer assigned an address,
this
or
is
is it still a null pointer?
confusing. Not gonna lie to you, but I'm gonna get
If
the
my
hang of it. I'm
pointer
gonna
is
get
still
the
a
hang
null
of it. I'm gonna
pointer,
get the hang
that
of it.
means we did not
Are we
successfully
supposed to
assign an
put?
address to my
Yeah,
pointer.
we're supposed
There
to
may be
put.
situations, such as when working with dynamic memory, where you attempt to assign an address to your pointer and it fails. This would be a good way to check to see if that failed or not. If
Backslash
your pointer
n.
still remains a null pointer. So let's say address was not assigned.
Okay.
Else,
Is
standard
it?
output, address was assigned. So let's run this. Currently our pointer is pointing to the address of x.
What?
Address was assigned. Now if for some reason we did not assign an address, I'll turn this line into a comment to represent that, well, our pointer is still going to be a null pointer. Address was not assigned. If your pointer is still a
Gotta
null
make the
pointer,
code look
it's
pretty.
not safe to dereference that
Feel
pointer.
me?
If I need access to the value that's at that pointer, it would be safe to do so within this else statement. Standard output, dereference operator, pointer. So my pointer contains the number 123. If I were to dereference this null pointer, that would lead to undefined behavior. I have no idea what's going to happen. Don't try this at home, kids. A null pointer is a keyword that represents a null pointer literal. When declaring a pointer, it's good practice that our pointer is pointing to a valid address or this null pointer keyword, because otherwise we don't know where it's pointing originally. They're helpful when determining if an address was successfully assigned to a pointer. When using pointers, be careful that your code isn't dereferencing a null pointer or pointing to any free memory that we're not using, because that can lead to undefined behavior. So yeah, everybody, those are null pointers in C++. Hey guys, in this topic we're going to create
Let's
a
do
game
it
like
like that.
tic-tac-toe. We'll be working with random numbers. You may or may not
Alright.
need to include this header file. Include
Mm,
C time. We'll add some function declarations, then some definitions.
Alright,
Void,
else
draw, board. There will be one parameter. A pointer.
now we
array,
gotta
and
see
spaces will be
100. It's
one-dimensional array
400
that
and
will keep track of all the
104.
markers, like what spots are
So,
taken, what spots are occupied. Player move.
else if
The parameters will be a pointer to spaces and char player. Computer move. A pointer to spaces,
that's not 100.
char
Okay.
computer. Check winner.
Else if
A pointer to
you're
spaces, char player, and char computer. Then lastly, check tie. And all we need is a pointer to our array spaces. Oh, check winner and check tie will both return a Boolean value. Okay, let's add some function declarations. So after the main
100
function, let's
equals to, how you show the equal to is two double signs, two equal signs. I'm pretty sure you can just use one equal sign. I don't know. Probably not.
Or check winner and check tie because there is a return type. Just for now, as a placeholder, I'm going to return 0.
But I don't know how you figured out you had to use
But
two
we'll
equal
change that
signs.
later.
But okay.
Let's head to the main function and declare everything that we'll need. A character array named spaces. The size will be 9 spaces. We'll have 9 elements, each contains an empty space. 2, 3, 4, 5, 6, 7, 8, 9. Good. Char player. Pick a character that you'd like to be. You can do X or something else. Char computer. Pick a character for the computer. Let's begin with O. Boolean running. I'll set this equal to true. When we begin our game, we will immediately invoke the drawBoard function. Then pass in our array. So remember, when we pass an array to a function, it decays into a pointer. So we don't need to create a pointer for this array. Within the drawBoard function, we will display a grid. So let's write something like this. Standard output, I'll add 5 spaces. 1, 2, 3, 4, 5. Then a vertical bar. 5 spaces again. 1, 2, 3, 4, 5.
Now we're adding the character output is equal if it's divisible by 4.
Then a new line.
Evenly divisible by 4.
Okay, let's copy this.
Wait. If it could be
Right in the middle.
if
I'm
it's
going to add
not
one of the
evenly
elements of
divided by
our array
400, then
spaces.
it's not
So
even.
right about there.
Okay.
Spaces at index 0.
If that year can be evenly divided by 100 and it's not evenly divided by 400.
Right in the middle between the 2 vertical bars. I'll paste
If the year can be evenly divided by 4, then it is a leap year.
That again. Right in the middle. Paste what you have. Spaces at index 2. This time we'll create a horizontal bar. Let's copy this. We'll replace the spaces with underscores. So right about there.
Oh, that's not right.
Okay, let's see what we have.
Where's
Okay, we have something like this. We'll have a player or the computer right in the center. So let's copy this line on top. Paste it underneath. Copy this line that displays elements of our array. Paste it underneath, but change the element numbers. 3, 4, 5. Then we'll copy this line. Paste it underneath. Let's double check to see what we have. Okay, we're getting somewhere. Let's copy this line. Paste it. Copy one of these lines. Display the elements of the array.
2 less than signs.
Paste it underneath.
Okay.
So we are missing
Definitely do not do
elements
that.
6, 7, 8.
Yeah, what the heck?
Let's copy one of these lines.
Now I'm in caps for some reason.
Paste it underneath.
Okay.
Then before and after,
Technical
display this grid.
difficulties,
I'll just display a new line. Standard
let's
output.
put is
New line.
a leap year.
Let's do that after.
Is a leap year.
Okay, let's see what we have.
Backspace.
There's our grid.
Backslash and
Okay, that is the drawBoard function. We can close out of this. We're done with it. When we invoke the drawBoard function, we will pass in our array, which decays to a pointer, and then prints our board. Let's add a while loop after the drawBoard function.
okay.
While our condition is running. Running is set to true initially. When we exit out of the game, we'll set running to be false. The first thing that we'll do is invoke the player move function.
Okay.
But we need to pass in our array,
Now
spaces,
I
as well as
need
player.
to do
Player. Then let's
4.
implement the player move function. Okay, player move. I'll create a local variable named number. The user will enter in a number between 1 and 9, depending on what space they like to occupy with their marker. I'll create a do while loop. Do
Else
while. The condition will be not number
here.
is greater than 0, or not number is less than 8. The user can only enter in a number between 0 and 8. Those numbers correspond to the elements of our array. Elements with indices 0 through 8. Within the do while loop, we'll ask for some user input, standard
0.
output, enter a spot to place a marker 1 through 9. Whatever the user types in, we'll just subtract 1. Because the user doesn't know that arrays start with 0, supposedly. Standard input, number. So the user will enter in a number between 1 and 9. Then we will decrement the number by 1. Because the array starts with 0. If spaces at index of number, whatever the user types in, is equal to an empty space.
Cat
If that
output.
space isn't occupied, we'll add that marker to that spot. Spaces at index
Two
of
lesson
number
signs.
equals
Here. Two
the
lesson
player's marker.
signs.
Then we'd like to break out this while loop. So after the player
Is
moves, let's draw the
not
board again to reflect any changes.
leap.
Okay, enter a spot to place marker. How about 1?
Okay, for
Yeah,
some
there's our
reason
marker. Let's try again. How about 9? Yep, and
yeah.
here the last spot, the bottom right corner. Let's enter a number that's
Backslash
outside of its
n.
range, like 100.
Always
Enter a spot
close
to place
your
marker,
statements with
-1. It's
semicolon.
limited to the numbers 1 through 9. Even if I were to type 0, we still can't. So let's try something in the middle. That would be 1, 2, 3, 4, 5. Yep, and there's our marker. I'm just gonna add a colon, then a space. Okay, that is the player.
Make the everyday extraordinary with L'Oreal Paris.
AWS AI is how Audi goes from concept to customer. It's how Bundesliga delivers real-time insights to fans. And how GoDaddy helps small businesses grow. AWS AI is how.
I can take CTE with me everywhere I go. I decided to go back to school, and I chose
Else.
so I'm at work and I have a break. I get my schoolwork. I know
Else if is to add more conditions
and opens up more doors.
to the if. So checking if your the remainder of 400 equals 0, and checking also and also. Else if is an also, else if and another also, and then else is to close it with a
Function.
like
We
a
can close out of this function.
like if it's a
Let's
disagreement.
work on the computer move function next. With the while loop, let's invoke that function.
So
Pass in our spaces array, as well as whatever character the computer is. Then we will draw the board again right after. Just update it. Within the computer move function, we'll create a local variable named number. We'll need a seed to generate a random number.
else
Rand. Within the parentheses, invoke the time function, pass 0 or null,
but come on.
and we should be able to generate some random numbers. So I'm going to create a while loop. While the condition will be true, I would like to generate a random number between 0 through 8. We'll take number, set is equal to
Cat
random
output
function,
else if it's not any of these or one of them are wrong,
and 8 technically.
it will
If
come
we
out
use a number
as
that's occupied already, we'll need to re-roll a random number. If spaces
is not a leap year. Well, no, it will come out. Please enter a valid 4-digit year.
We'll take spaces at index of number,
Yeah.
set is equal to the computer's marker, then break out of the while loop. Let's test this function.
Count.
After we pick a spot, the computer will pick a spot too. Yep, so the computer picked a spot right in the middle. Let's try it one more time. I'll pick a spot in the middle again, so that would be 5. And our computer picks spot number 2. Cool. Let's close out of the computer move function. After
Valid
the player moves, then we draw the board again. We will check
for
a winner. I'll use an if statement. Within the condition of the if statement, we will invoke the check winner function. The check winner function returns a Boolean value, so that's why we're placing it within the if statement. But we need to pass in a couple arguments: our spaces, the player, and the computer.
misclicked.
If there's a winner, if this evaluates to be true,
Here.
we will set running equal to false.
Please enter for
then
valid
we will
4-digit year.
Let's add this if statement to after the computer moves to. Okay, let's fill in the check winner function. So right down here, we'll need to check all of the different win conditions. There's several.
Backslash.
Normally I would use a switch, but it's going to get very complicated, especially for beginners. I think just to make this easier, we'll use a bunch of if and else if statements. Within the first condition of the if statement, we'll check to see if the first row all has matching characters. So we can do that by saying spaces at index of 0 is equal to spaces at index of 1 and spaces at index of 1 is equal to spaces at index of 2. If all three characters in the first row are the same, that means that somebody won. I'm going to use the ternary operator here. We have to determine who won, the player or the computer. Let's check to see if the first index, spaces at index 0, is equal to the player's marker. Ternary operator, like we're asking a question. If the player occupies the first row, then we'll print standard output you win. Otherwise, standard output you.
Something's wrong. Something's wrong. I'm missing the bracket.
Then I'm just gonna add a new line here and here.
Where did I miss the
And there's
bracket?
one more thing we have to do with this condition, and I'll explain that. So let's run this. I'll pick spot number 9. You lose. The reason that we lost is that we're checking to see if the first row all has the same characters. They're technically all empty spaces, so our program thinks that somebody won because all of these characters match. There are 3 empty spaces. I'm going to amend this if statement. We'll want to ensure that none of the spaces are empty. And really, we only need to check the first space. I'll make this amendment. Spaces at index of 0 does not equal an empty space. And all these other conditions. If you'd like to keep this more organized, you can always surround some of these conditions with parentheses. I think it's more legible that way. Let's try that again, just to be sure that it's working. I'll pick something in the middle. Okay, yeah, so the computer doesn't win automatically if there's 3 empty spaces in the first row. Okay, so that is the first win condition. Let's copy this condition. I'll add else if. Now we'll check the second row. If spaces at index 3 is not equal to an empty space, and spaces at index 3 is equal to spaces at index 4, and spaces at index 4 is equal to spaces at index 5. Then does spaces at index 3 equal
I'm just run this.
Okay, so that is row 2. Let's copy and paste that else if statement. Then we'll need to check the last row. Spaces at index 6.
I think you could do
6 is 6 equal to 7, and is 7 equal to 8. So these conditions will check all of the rows.
Okay, buddy.
Then we'll need columns. Let's copy one of these else if statements, paste it. So we have 0, 0 is 0 equal to 3, and is 3 equal to 6. Okay, now talk to the second column.
CPP.
Spaces at index 1. 1 right here as well. Is 1 equal to 4, and is 4
Bro,
equal to
I
7.
know, damn right.
Copy this again, paste it. Then we have the third column. 2, 2 is 2 equal to 5, and is 5 equal to 8. Okay, now the diagonals. Spaces at 0, 0 is 0 equal to 4, and is 4 equal to 8.
What is wrong with my code?
Then the last diagonal.
Oh, this is gonna bug me out.
Spaces at index 2. 2 is 2 equal to 4, and is 4 equal to 6. there's no win conditions,
Mm.
we'll have an else statement. We will return false. Then all we have to do at the end of this function is to return true. Somebody won. Okay, so let's
Why
test
is
this.
this?
I'll try and win with the first row. 1, 2,
It's not
3.
right.
You win. This time I'm gonna try and lose.
It's
1,
not right, bro.
2,
No, it's right.
4,
Bro, oh my god.
7. Oops,
Alright.
7's taken. 8.
G
There we go. You lose.
plus
We can close out the check
Plus.
function. We know that it's working.
leap
Then we just need to check to
year.
see if there's a tie. If there's no more spaces available.
That's
Within the main function, after our if statements, we'll
What?
have else if. We'll invoke the check tie function. Pass in
This
our
makes no
spaces.
sense. It makes no
Check
sense.
tie returns a Boolean value. If it's true, we will set running to be false. Then break. Then add that after the computer move section too. So right here. Then let's fill in this function. Within the check tie function, we'll iterate over the elements of our array spaces. We'll use a for loop. For int I equals 0. We'll continue this as long as I is less than 9 because there's a total size of 9 spaces. Increment I by 1.
What happened to my
Spaces at index of I is equal to an empty space. That means we can continue. Return false. There's still empty spaces. If we iterate over our array and there's no empty spaces, well then we'll display standard output. It's a tie. Add a new line. Then we will return true. And we get rid of that. Okay, so let's close out this check tie function. Then after we exit our game, outside of this while loop, let's display a message. Standard output. Thanks for playing. Alright, and that's everything. Let's run this. I'm gonna try and get a tie this time. 1, 2, 6, 7, 8. It's a tie. Thanks for playing. Alright, everybody, that is a game of tic-tac-toe for beginners. If you would like to copy of this code, I'll post this in the comment section down below. And well, yeah, that's a game of tic-tac-toe using C++. Hey everybody, we finally made it to dynamic memory. Dynamic memory is memory that is allocated after the program is already compiled and running. To allocate dynamic memory, we use this new keyword. It's an operator. It allows us to allocate memory in the heap.
I fixed it.
It's useful when we don't know how much memory we'll need. It makes our programs more flexible, especially when accepting user input, because we have no idea what the user is going to type in. Here's an example. We'll start with a basic integer variable, but we'll allocate memory in the heap rather than the stack by using that new keyword. I'll create a pointer. Int.
What? It's still wrong.
Key num. Now it's good practice when you declare a pointer, but don't assign it right away, to give it a value of null.
But the declaration.
To allocate memory in the heap rather than the stack, I'll take my
Like
pointer,
global
set
scope.
is equal to, use the new operator, then a data type. I'll use up enough space in the heap for one integer. The new operator will return an address. We're storing that address within pnum.
Run this.
Run this. Memory location where we're going to store an integer. Later on in your program, whenever you would like to store a value, we can use the reference operator. Our pointer then assigns value.
What?
21.
Oh my gosh.
I'm going to display the
Bro.
address that's stored within the pointer.
What did I do wrong?
Pnum.
What did I do wrong?
As well as the value.
Expected declaration before.
The reference operator. Pnum. Our pointer is storing this address, and at this address in the heap, that address contains this value, 21. Now, it's very good practice, if not expected, whenever you use the new operator, you'll also want to use the delete
Oh,
operator
what
when
is
you're no
this
longer
doing
using that
here?
memory space. So at the end of the program, or
Ah.
earlier if you choose, we will delete our pointer.
And what a
Delete P
small
number. We're
mistake.
freeing up the memory at this address. If you don't, you may cause a memory leak, and it's best to avoid that. Whenever you use the new operator, you probably should be using the delete operator someplace within your program.
Okay,
Here's
still
another
wrong.
example. We're going to dynamically create an array. Let's create an array of grades. Char, then we'll need a pointer, the reference operator, P grades. Set this equal to null if we're not going to assign this pointer right away. Then to dynamically create an array, we will take our pointer, set this equal to new, the data type, char. If this is an array, we add a set of straight brackets. Within the straight brackets, we will list a size. If I have 5 grades to enter in, I would type in 5. But if we already know the size of the array before we even run the program, we might as well do that normally, like create a normal array. There's no point to allocating memory dynamically.
Oh my god, I have so many mistakes in here.
So I propose we ask for some user input.
I wonder if I could do a project without making a mistake. That's kind of hard though.
We'll create a prompt.
You're gonna make mistakes. It's bound to happen.
How many grades to enter?
And there you go. Now, moment of truth.
Size will dynamically allocate enough memory in the heap depending on how many grades the user has to enter.
Into the 4th year. Alright, so 2000. Boom. 2000 is leap year.
I will continue this as long as I is less than size.
2008.
Standard.
Oh, okay. You can't enter it again. 2000 is leap year, but basically it did it.
Because I only need 0 to begin with. And I'm just gonna add colon space afterwards.
Now let's see what happens. I don't like how you had to keep doing.
P grades. That's our pointer.
G plus
now
plus.
either add plus I or use those straight brackets at index of I. Either way.
Here. CPP.
Let's display all of the grades.
A.
Int I equals 0.
Out.
I is less than size.
Let's try 305. Please enter valid 4-digit year.
I'll separate each with a space. And remember, if we no longer need this array, we should delete it to prevent a memory leak. If we have to
there's no try again feature.
After delete, that are pointer.
Okay, I didn't enter a try again feature, but I learned that in something else.
And let's try it.
But I basically did this.
How many grades to enter in? So we don't know what the
I did
user is
that.
going to type. Let's say 6 grades. Enter grade 1. A, B, C, D, F, A. And here are the grades. So that's why dynamic memory is useful. It's memory that is allocated after the program is already compiled and running. We use the new operator to allocate memory in the heap rather than the stack. It's useful when we don't know how much memory we will need. It makes our programs more flexible, especially when accepting user input. So that is an introduction to dynamic memory. We'll have more practice with this in the future, so don't worry. If you would like a copy of the code that we worked on, I'll post that in the comment section down below. And well, yeah, that's an introduction to dynamic memory in C++.
New Crispy's meals launching now. Always more to explore. Buy now. The triple stack fruity blast with a soft.
Alright, the Magic 8 Ball is a super popular toy used for fortune telling or seeking advice developed in the 1950s by Magic 8 CPP program that will output a random fortune each time it executes.
Try crust.
Okay.
Your time matters.
How long have I been streaming so far? Let's see.
Mika, we make protecting the light beautiful.
49 minutes, that's not bad. I did a whole project. Y'all saw me do a whole project. Oh man.
Your resume says you're a professional for
So
Mr. Clean Professional lifts away grease and grime in half the time.
You know the exploratory white?
You're hired.
Try Mr. Clean Pro, now available at Restaurant Depot.
Hey guys, I gotta explain recursion. Recursion is a programming technique where a function invokes itself from within. We break a complex concept into repeatable single steps. Many problems we can approach iteratively or recursively. Some of the
Okay.
advantages of recursion include less code to write, and typically it's cleaner. It's also useful for sorting and searching algorithms. However, some of the disadvantages of recursion is that it uses more memory and is slower. There's a trade-off. It's up to you if you'd rather use an iterative approach or a recursive approach. Here's an example. We'll break a complex concept, maybe such as walking, into repeatable single steps.
This project is gonna be harder, but I'll come back to this. This is part one of learning how to code, becoming a programmer, mainly a game developer one day. But yeah,
a number of steps.
I'm doing Code Academy right now. This is crazy. This is a lot. I'll come back later at this. I need to eat something. So
Int I equals
yeah.
0. We'll continue this as
Peace, guys. Peace.
Is less than our steps.
Oh, actually, I wanted to do something.
I will display. Just you take a step. Then I'll add a new line. So we will invoke this function, pass in how many steps we would like to walk. I would like to walk 100
Action
steps.
movie, yeah, that's cool.
And here we go. We printed, you take a step 100 times. This is an iterative approach. If we were to take a recursive approach, we would invoke this function from within itself. So I'm going to turn this for loop into an if statement. We'll need a base case. When do we stop?
If steps
is greater than 0, we will display you take a step. Then I'm going to invoke the.
Alright, but peace out.
Then I will
Peace out, gang. Stay tuned.
-1. This would be a recursive approach.